Greetings and welcome, friends. Mr. Wada here. It's a big day for math. This is like, I said it to my class earlier, but I'll let you know as well, internet friends. Like really internet friends. You and I, we're buds. Let me be honest with you. Slope-intercept form is probably top 3 Algebra 1 concepts. Top 3, that's my thought. All right, just letting you know. You got slope-intercept form, you are picking up points in Algebra 1. It's going to be amazing. So here we are. This is section 3.5. We're talking about graphing linear equations. We're graphing lines using slope-intercept form. But before we get to slope-intercept form, you might be like, well, what is slope? I heard about intercepts yesterday, but what is this slope? And here we go. Slope is the rate of change between any two points on a line. Okay? It is the measure of the steepness of the line. To find the slope of a line, okay, here we go. Ooh, these are pro tips. Find the ratio of the change in y, okay, the up, right, piece, to the change in x, the over piece. So slope is equal to the change in y, all right, they actually should have done this one first. Change in y, which is this one's moving up 3 squares, right, 3 units, to the change in x over 2 units. So the steepness of the line is going to equal 3 over 2. Up 3 over 2. And actually, this slope is consistent between any 2 points on this line. The ratio. Now, it might not have had as nice numbers, but if I was to reduce the fraction, it would have become that. Notice this. From this point, watch this, to that point, the rise, the change in y is up 6, and the run, the change in x, is 4. And what does 6 over 4 reduce to? Reduces to 3/2. Isn't that cool? So even if I picked points that are further apart, it would still simplify to being exactly the same slope. All right, and notice that for a line, it's got a constant rate of change we talked about a few sections ago. So notice from this point to this point, it's up 3 over 2, up 3 over 2. Here they thought of it as over 2, up 3. Also, watch this. This is pretty sweet. 3 over 2, I just want to point out, is the same as negative 3 over negative 2. You guys believe that? Because, right, a negative divided by a negative is positive. So watch this. In negative bizarro world, to go from this point, I could go down 3. And watch this. Ready? And backwards to the left. And notice I'd land on another point on the line. How cool is that? What? It even works if I make the rise and the run negative. I love this. This is so good. You guys, get ready to get pumped. Talking about slope. So that's kind of the simpler way to think about it. I'm gonna try to present slope to you in as many ways as I can, so it clicks. So here's more of a mathematical presentation of it. Okay. So the slope m, all right, we just gave it a name. We gave it a constant. M is how we're going to refer to slope. M, think mountain for slope with steepness. All right, don't worry. Cool. So the slope m of a non-vertical line passing through 2 points. So here's just 2 random points. They're written as x1, y1, and x2, y2. So point 1 and point 2, just pretend there were any 2 points, is the ratio of the rise. Okay, why did they keep committing to like doing the rise after the run? I feel like their blue arrow, they should have done the blue arrow first. Yeah, the rise and then the run, okay? So the rise is the change in y, to the run, the change in x, okay? So rise over run, that's often a way that I'll describe slope for us, okay? I think that's easier to think of than this one, change in y over change in x. So if I wanted to calculate this distance, it would be the y2 value subtracting the y1 value. So the rise is the difference of those points' y coordinates. You believe that? All right, just think about it, right? So how tall is this? How low was that? Subtract those numbers. That will give me how far up I went, what my elevation change was. Good, good? All right. And the change in x is actually going to be the same idea. The difference of the x coordinates. So if this was 5 and this was -1, all right, already getting complicated. If I did 5 minus a -1, that's 5 plus 1, this would have been 6 across, 6 units across. All right. If I want to find the run, I just subtract the corresponding x coordinates. And notice that they put the 0.2 first and the 0.1 second. Whichever one you call 0.1 and 0.2 doesn't matter, but once you've chosen a name, you've got to commit. All right, you've got to commit to calling that 0.1 indefinitely. All right, and so you do the subtraction in the same order each time. All right, so let's do our first example. You guys got your little follow along packets. Here we go. Okay. It says describe the slope of each line, then find the slope. Okay. Let's talk about just positivity or negativity. All right. Now slopes, as Mario runs to the right, is Mario going uphill or downhill for this problem? He's going uphill. So this is a positive slope. All right, as Mario runs to the right, he'd be sliding down this, and he's going downhill. So this is a negative slope. Might run out of space. Negativo, right? Now, if I want to find the slope, we've just talked about a whole bunch of different ways to do that. The slope for this is the rise over run. So from this point to that point, I could have done up 4, which they also denoted there, and over 6. So up 4 over 6. So 4/6. Notice happens to be positive. It is my slope. And that reduces. 2 goes into 4 twice and into 6 3 times. That means my slope for this, I could have done up 2 over 3, up 2 over 3. And if I start at a point, I'll land on another point on my graph. I also could have found the slope using the coordinates and the slope formula. All right, let's give myself some space here. So the slope formula, m is equal to y2 minus y1 over x2 minus x1. Let's plug in what we got. Actually, better yet, let's label what we got. Let's label this x1, y1, and this one x2, y2. Right, I could have found that point. How could I have gotten to that point from the origin? Left 3, down 2, so -3, -2 are the coordinates of that point. And if I want to find the slope using the formula, I would have done y2 is 2, minus y1 is -2, careful of that double neg, over x2, which is 3, minus x1, which is -3. So let's simplify that. 2 minus -2 is 2 plus 2, which is 4. And 3 minus -3 is 3 plus 3, which is 6. And notice I'd actually get exactly the same value. I get m is equal to 2/3. And notice the sign of m. This is a positive number, which is the positive slope that we were talking about just a moment ago. So let's look at this one. For the sloppy slope, let's do rise over run. Rise, well, it's not rising, it's falling. So I'm going to describe the rise as a negative. So it's -3 is the change in y, -3. And what's the run between these points? How far to the right did it move? With me, friends? How far to the right did we move here? 2 units to the right. So rise over run is -3 halves. I get negative. Hey, negative. Remember, I also already described that as a negative slope earlier, right? So positive slope, positive fraction. Negative fraction, negative slope. Same idea. Let's do this one using the formula as well. We'll label our points. X1, Y1, X2, Y2. And I do want you to label your points on homework just because that's the most common mistake is just plugging the wrong thing in the wrong spot. So M equals -1 minus 2, right? I'm just using this formula, over 2 minus 0. I'm going to get m equals, let's see, negative 3 over 2 minus 0 is 2. So I get the same exact value. Not too shabby, right? Not too shabby. Let's do some real quick. Watch how quick this is going to be. We'll do non-formula slope for these, but you do need to know how to use the formula, okay? Let's see, slope of the line. Do you think, all right, line 1, let's have Austin tell us, positive or negative slope? What do you think? As Mario runs to the right, is he going uphill or downhill? Downhill, so negative slope. And let's see, if I want to find the slope, what is the rise? To go from this point to that point, I'm going down how much? So we'll call that negative 2. And what is the run to go from here across? Might be hard to count from that distance. Looks like 5. So my slope, rise over run, is going to be negative 2 over 5, negative 2/5. Good, good. Let's see, Tyler, let's take a look at this one. As Mario runs to the right, is he going up or down? Up, so that's a positive slope, okay? And let's see, to find the slope, let's think rise over run. So, rise, I've been using red. So from this point to get to the next point, I'm going up this number. Looks like 4, so the rise is 4 units. And the run is, yeah, it looks like 6. So the slope for this, rise over run, 4 over 6, that reduces to 2/3, up 2 over 3, up 2 over 3. And let's see, I'll do this one. This is a positive slope because Mario runs uphill as he's going to the right. And let's see, the rise, the y, change in y, is up. Oh, let's see, wait a minute. Oh, wow, ooh. Guys, they almost tricked me. Look at, they changed the scale. These squares are counting by 2. So let's see, the rise, to go from negative 3 to 4, went up 3, then up another 4. This is up 7. Wow, they almost got me. You saw that. They almost got me. And the run is going from 2 to 5. To go from 2 to 5, I need to move 3 units. So the slope is going to be 7/3. Boy, that was a tricky one. They almost got me. Touche, book. Touche. Let's see. Let's talk about slope from the perspective of tables. Might be as far as we get today. We'll see. All right. So the points represented by each table lie on a line. So these are linear. Okay. How can you find the slope of each line from the table? Well, slope, remember, is change in y divided by change in x. Okay, so let's find the change in y. So for this, I'm going from 20 to 4. I'm going down by what number? Down by what number? Friends? 20 to 14. Oh, I said 4. 14. To go from 20 to 14, what did I do? I subtracted. You guys are so shy. Let's see, 20, what do I subtract from 20 to get 14? There we go, 6. So the change in y was 6. What was the change in x over the same points? It was going up 3. So the slope for this is down 6 over 3, which can reduce to be negative 2. Which actually, it might still be helpful for you to think of that as negative 2 over 1, and I'm fine with that for rise over run. We still got 3 minutes, hold on. Let's see, for change in y, 0 change for y. What's the change in x here? To go from negative 1 to 1, I was adding 2. Those are 2 units away. So the slope here would have been 0 over 2. What's 0 divided by 2? Yeah. What kind of line was it when we had a slope of 0? Do you remember? What did that look like? How steep is a line with a slope of 0? It's flat. It's horizontal, right? So this would be a horizontal. It has no change in y. Let's see, let's look at this last one. The change in y, this is going up 3. And the change in x is, 0. Now this one's going to be interesting. This one's really interesting, actually. So the change in y was 3, the change in x was 0. What's 3 divided by 0? That's actually undefined. That's weird. All right, so we call the slope undefined. We also might say no slope. And that's when the line is so steep, it's a vertical wall. It's a vertical line. All right, so that's kind of an interesting situation. Let's see, the bell's going to ring in a minute. I think I'm going to do one last example. Yeah, so I might keep going again like I did last time, just to have this all on the video. But the homework, as you guys know, is online. You can quietly leave when the bell rings. Here we go, concept summary. Positive slope, Mario is going uphill when he's running to the right. Negative slope, Mario is going downhill when he runs to the right. Slope of 0, Mario's just like, cool. He's like, man, like I could do this all day. Just like, whoop, doo, 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 doo. Right? And then undefined slope, it's just like Mario, doo, 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 doo. Right? Mario just died. He fell down a pit. That is too steep. Right? So the line is vertical in that case. So no, we don't want that. Let's see. So you guys have a good day. I'm going to show this one more concept, which we actually already showed to you visually using GeoGebra. And all we're going to do with this is identify things here. So let's see, slope-intercept form. Okay, a linear equation written in the form y equals mx plus b is in slope-intercept form. The slope of a line is m, and the y-intercept of the line is b. Okay, so slope is the coefficient, or the number in front of the x once it's solved for y, and the y-intercept is b, the constant that's being added to that. And now the value of this is that I will start to graph a line eventually. I will start at my y-intercept, and then I will move by my slope. So I'll do the slope, the rise, and then I'll move by the run, and I'll end up getting another point on the line. And then once I have 2 points, I can draw the line, right? So what we're going to do is just simply identify what is the slope and the y-intercept when I have that form. So I'll just do these last couple of problems here, and we'll call it a video. Have a good day, Tyler. All right, so here we go. I've got some new guests along with my internet friends that I'm recording live for. Good times, welcome. We're talking about slope-intercept form. If I want to find the slope of y equals mx plus b, the slope is the number in front of the x, so m is equal to 3. If I want to find the y-intercept, the b, it is the number that is being added to that. In this case, it includes the negative. So the slope is 3, or 3 over 1. And the y-intercept is negative 4. Now this next equation is a little bit funny. I've got y equals 0x plus 6.5, if it helps you that way to think about it. And so the slope is 0. It's a horizontal line, which we already knew that from our standard form stuff back in the day. And the y-intercept is 6.5. Let's see, this last problem isn't in slope-intercept form. I've got to solve it for y. So let's solve for y, add 5x to both sides. You guys are experts at solving literal equations. Negative y, or the opposite of y, is equal to 5x minus 2. And then I could opposite everything or divide everything by negative 1, whichever way you want to think about it. And I will get y equals negative 5x plus 2. And so my slope, let's see, Angela, what do you think the slope is here? Yeah, the slope is actually the negative 5, the coefficient of the x term and the y-intercept is positive 2. All right, well, thanks for watching, Internet friends. Hope you have a great day. Bye-bye.